Hello, so this is another quick video showing you solutions to the polynomials homework. Okay, without further ado, let's have a little go at this. So, when I look at simplifying algebraic fractions, really there's only a couple of tricks. There's an extra trick you need when you're handling fractions within fractions, and that is to get rid of the fractions within fractions in the first step. Otherwise, though, if you've got these kind of situations, the trick is always factorize, then cancel. Whatever you do, don't start doing this. X squared over x squared is just 2 over that. The reason why that doesn't work, by the way, and I'd like to quickly show you why that's definitely a no-no. If you've got 5 plus 7 over 3, for example, obviously that's 4 because you're doing 12 divided by 3, which is 4. Oh, hang on. Can I make this? Let me just make this slightly nicer. Let's make it 6 plus 6 plus, let's make it 9 divided by 3. Obviously, that's 5 because you've got 15 divided by 3, which is 5. You can't do something like this. 6 over 3 is just 2, so it's 2 plus 9, which is 11. And you can see it's not working there, can't you? Because the answer is supposed to be 5, and we're getting an answer of 11. What you should always do before cancelling that, and I'm just showing you with numbers, obviously we wouldn't do it this way, but you could factorize out the 3 in both the terms there. So you get 3 times 2 plus 3 over 3, and then you cancel out the 3's and you get the 5. If you say, I mean, that's what you should be doing. So you can't cancel a term here with a term on the bottom. You have to factorize first. So you've got a product. That's when we can cancel. If you've got why can we cancel 48 over 90? Well, it's because both the top and the bottom are going to be divisible by 6 here, and you can make that 6 eighths, and you can make the bottom 15 times 6, 6 times 15, which is 90. And that's why the answer is going to be 8/15. But you always make sure you've got a product, then you can start crossing things out. So let's try and do this. What does that top factorize to give? It's going to be 2x and x, and then we've got a plus 5x minus 3. I'm a guesser on these ones, so I'm going to guess at like plus 3 here and minus 1 there. I think that sorts it out because you get plus 6x minus x. That's good. And then on the bottom, that's difference of 2 squares, x plus 3, x minus 3. And you expect to see the same brackets on the top as on the bottom. And so you get 2x minus 1 over x minus 3. Next one's got a little bit of a sting in its tail. Top can't be factorized, but the bottom can be factorized to give you 5 times by x minus 5. Now, this is something that few understand. But a minus b is the negative of b minus a. Yeah, that's a fact. Because if I was to apply this negative throughout the brackets, I would get minus b plus a, which is a minus b, because I could just rearrange it. Think of it with numbers. 3 minus 5 is a negative of 5 minus 3. Or perhaps it's easier to look at it the other way around. 5 minus 3, well, 3, no, maybe it's easiest the first way around. If I did 6 minus 7, that's minus 1, and that is a negative of 7 minus 6. Do you see what I mean? It's minus 1. And that's all we're saying here. So anyway, what that means is if you've got a minus b divided by b minus a, that's actually the same as a minus b divided by the negative of a minus b, because I can move that minus onto the other side, or you could write right at the top as minus b minus a. Perhaps it's easier to show you it like that. But the point is, you get minus 1. Yeah, you always get minus 1 if you do a minus b divided by b minus a. Use numbers if you're not convinced. But what that means is over here, we need to make this minus 1/5. And that's quite subtle. I think most will miss that. I really do. I'd be surprised if a significant number of students didn't miss that. Now this one, if we just times by the lowest common multiple of 2, 3, and 4, which I think will be 12. I don't think we can do better than that, can we? Yeah. If we times top and bottom by 12 here, we're going to get rid of all of our fractions within fractions. Now, 2/3 of 12 is 8, half of 12 is 6, and a quarter of 12 is 3. And then I've got it nicely tidied up. I don't think that can be factorized any further. I suppose you could write it as 6x divided by 3 is 2x. You don't have to do this. I would personally give that a tick at that point because it's fully you've taken out all common factors and cancelled. But just in case you were paranoid and you thought, oh, I might want one extra line, well, that's going to be 2x. And then if you do 8 divided by 3, that's like 2 1/3. Because you can write this as two separate terms, as 6x over 3 plus 8 over 3. 2 1/3, 2 2/3, Mr. Nichols. Dear, oh dear, got that one wrong. I think that's right now, 2 2/3, because 3 goes into 8 twice, remainder 2. And the remainder still needs to be divided by 3, but you don't need that extra line. Okay, right, let's get into the factor theorem bit. This is the interesting bit of this kind of question. I like the factor theorem, I really do. Given that f of x is exactly divisible by 2x minus 1, that means that when we plug in a half, it should equal 0. Now, plug in a half, you're going to get 1/8, because half cubed is 1/8, so you're going to get 6 over 8. Plus, now half squared is a quarter, so we're going to get p over 4. And then we're going to get q over 2. Then we're going to get plus 8 equals 0. Yeah, that's just from that fact. So we've dealt with that fact. Now, also, when it's divided by x minus 1, the remainder is minus 7. So that means when we plug in 1, well, we're going to get 6 plus p plus q plus 8. That one's easier to do. It should equal minus 7. Now, what is this? Well, we've got an equation with 2 unknowns. We've got a different equation with 2 unknowns. That's simultaneous equations every time. Tidy up carefully, though. This one's easier to tidy up because you just get p plus q that's 14. Dump it on the other side, you're going to get minus 21. Let's call that equation A. This one is harder to tidy up. Personally, what I would do is times it all by 8 because you're going to get rid of no, let's times it by 4 because that's actually 3/4, so we can do better than 8. So if I can just work with this one over here for a second, I'm just going to times it by 4. 4 times 3/4 is 3. 4 times p over 4 is p. 4 times q over 2 is 2q. And then 4 times 8 is 32 equals 0. So we get p plus 2q is minus 35. So I'm going to write that down here now. And that's going to be like my b. And then what I'm going to do is I'm going to subtract b minus a, I think I'm going to do. Careful with the sign errors here. 2q minus q is q. Minus 35 minus 21 is minus 35 plus 21, which is minus 14. And if q is minus 14, p needs to be minus 7, I believe. Check it works in both equations as well. Minus 7 minus 28 is minus 35. So we've done it. We can see now that f of x is equal to, apologies, I tend to go all over the place with my working out, which is not a good habit. 6x cubed minus 7x squared minus 14x plus 8. Now it says, hence factorize f of x completely. Now this is the bit I like. Now I do not use long division. I do not like long division. I find it hard. And so I'm not going to do long division here. I'll show you what I do. I know this is a factor because it's exactly divisible. So what I'm going to do is I'm going to find the quadratic that multiplies by this to make this cubic, which I wrote down here. Because a bit like the person who, rather than subtracts, adds when they give you change. I always find bus drivers are like this because they're, sensible people, and they realize that adding's easier than taking away. So if the bus fare costs like £2.20 and you give them a £5, what they tend to do is say 80p makes £3 and another £2 makes £5. They add on rather than take away. I'm a similar person. Rather than dividing, I times. I say what needs to times by 2x minus 1 to make 6x cubed minus 7x squared, so on and so forth. Well, it must have a 3x squared in it because that will give me the 6x cubed. Lovely. I've got that term. Now, it also gives me a minus 3x squared, but I want minus 7x squared. And so I need another minus 4x squared to make the minus 7x squared. And to get minus 4x squared, I need a minus 2x there, because that would give me a minus 4x squared. That gives me minus 7x squared. But it also gives me a plus 2x. Now I want minus 14x, which means I need this to be minus 16x. So overall, I've got minus 14x, which means this must be minus 8. That gives me the minus 14x overall. it also gives me a +8, which tells me I've done it right. And so I like that way of doing it. So I've partially factorized it now into 2x minus 1, 3x squared minus 2x minus 8. Now, you can normally do one better than this by factorizing your quadratic. I'm guessing that this is the case here. 2x minus 1, 3x, and an x. Let's see, what have we got here? Let's have a little think. We need it to multiply to give minus 8. I think we're going to get 3x plus 4 and x minus 2. Is that going to do the job? Plus 4x minus 6x is minus 2x, and then we get minus 8. Yep, it's fully factorized. Happy days. I hope you don't mind me doing it like that. If you use long division, it's not wrong. I just think it takes a little bit longer. But whichever way you're comfortable with, I think it's fair to say that's the best way to do things in the exam. If you're comfortable with that, that's good. Okay, very similar question, question 3 here. The remainder when it's divided by x minus 1 is equal to the remainder when f of x is divided by 2x plus 1. So what do we know here? We know that when we plug 1 in, we get p plus 6 plus 12 plus q equals, now that's just plugging in f of 1, and that remainder is equal to the remainder when you divide it by 2x plus 1, which means we need to plug in minus a half. So we get p times minus a half cubed plus 6 times minus a half squared. Don't rush this bit because you need to get this bit right. Plus 12 times minus a half plus q. Now my initial thoughts here are the q's cancel, which explains why it only asks us to find p first, because that's all we can find from that information. And what we're going to end up with is 18 plus p equals, now this is going to be minus p over 8 plus 6 over 4 minus 6, and there we go, we've got it. And then I think what I'll do is I'll add that minus p over 8 to the p over there, giving me 9p over 8. And then I might think of that as 1.5 minus 6, so that's minus 4.5. But then I'm going to take away 18 from minus 4.5, leading to minus 22.5. It might be wiser, though. I'm not working with a calculator here. You can work with a calculator if you want to. But I think I'm going to write that down as minus 45 over 2. My point would be, though, if you want to do well on the extension papers, and sometimes if you just want to save time, it's much better if you can do a lot of this without a calculator. It really is. You can use a calculator, don't get me wrong, but you know, it's nice to do it without. Now, 8 times minus 45 over 2, well, because it's over 2, it really becomes minus 45 times 4. Well, double it and double it again, you're going to get minus 180, and therefore P is minus 20. Done. Okay, Q is 3, and P has a value found in part A. What are we going to do? Well, we're going to plug all this in. We're going to find the value of the remainder. So we know f of x, let's just write down f of x first, is going to be minus 20x cubed plus 6x squared plus 12x plus 3. And then they just want us to find the value of the remainder. Well, it's probably easier to chuck in x is 1 because we always chuck in what makes the bracket 0. And so f of 1, well, that's going to be minus 20 plus 6 plus 12 plus 3. And that comes to, what is that? 1? I think it comes to 1. That's the remainder. Let's make it nice and clear to the person marking it what we've actually done there. Okay, right. Number 4. Okay, we've got a cubic here where a and b are constants. When x minus 3 is divided by 14, when it's divided by x minus 3 remains 14. When it's divided by x plus 1, the remainder is minus 18. So there's lots of remainder theorem in this homework, and that's good because remainder theorem is really, really useful. So let's just plug in f of 3. We're going to get 27 plus 9a plus 3b minus 10. And we know that that equals 14. Yeah, normally we don't work with this bit. It's just a convenient notation. When we plug in minus 1, the remainder is minus 18. That's going to give me minus 1 plus a minus b minus 10. And that should equal minus 18. Now let's do a little bit of tidy up and collecting terms. We get 9a plus 3b equals, and we're just trying to dump all the numbers onto the other side. You're going to get 24, but take away 27, you're going to get -3. And you could divide that all by 3. Here, you're going to get a minus b equals, okay, add the 10 on, you're going to get -8. Add the 1 on, you're going to get -7. And now we can times, well, let's just divide this one by 3, actually, because it lends itself to division by 3. And now solve simultaneously. You get a minus b is -7. I'll zoom in a bit so my pen isn't so scratchy. So let's quickly finish this off. We get, write this one down underneath, a minus b is -7. Add them together, you get 4a is -1 plus -7, well, that's -8. So that's a is -2 and b is is 5, I think, because -2, take away a +5 is -7. Always check that it works in both equations. So I know it works in this one. Check it works in this one as well. I'm going to get -18 plus 15 is -3. I check because I know how many careless errors I make. It's normal for me, so I always check. There's so much in the maths exam where you can check your answer, and it's really good practice to start doing that. Okay, let's do part B now. Show that x minus 2 is a factor of f of x. Well, that's a way of checking your answer as well, isn't it? They're giving you a way to check your answer here because the last bit will work out. But let's just write down what f of x has become. It's become x cubed minus 2x squared plus 5x minus 10. Right, x minus 2 should be a factor. So when you plug into, it hopefully equals 0. We get 8 minus 8 plus 10 minus 10. Well, those two terms cancel and these two terms cancel. That equals 0. Now, you must write this down at the end. Hence, x minus 2 is a factor. Yeah, you don't write that down, you lose a mark. So write down a little concluding remark. Remember, maths is communication. You want full marks in the maths exam, you have to communicate clearly. Okay, use the factor theorem to show that x plus 3 is a factor of this. So we're doing the same stuff again. We're just going to say, you know, I would personally start this question by writing let f of x equal that, then f of minus 3 equals, we're going to get -27, we're going to get then -27, then we're going to get plus 30 plus 24. Now, -27 minus 27 is -54, plus a 54 makes 0, yeah? And then you have to say, hence, x plus 3 is a factor. So please write down that concluding remark. I try and write down as little as possible as well. If I'm writing something down, you bet it's worth a mark, because just like a lot of students, I'm pretty lazy, really, but I'm going to try and avoid losing method marks. Okay, right, let's factorize this completely. Now, once again, I'm going to use this. I don't use a long division of polynomials. I just find it tedious. So like I described before, I'm going to try and find the opposite. I'm going to try and find something which times this to give this to make that. Yeah. Now I can see straight away it must start with an x squared because I need an x cubed. Now that also gives me plus 3x squared. But I need minus 3x squared, which means I need to take away another 6x squared to make sure I've got minus 3x squared overall. I've got that term. Now I've also got this term, but it means that this must be minus 6x. This is kind of like division by logic. That's what I would describe it as, division by logical progression. Now it also gives me a minus 18x when I do minus 6x times 3. Now I want minus 10x, which means I need a plus 8x. So that's going to be plus 8, and that's going to be plus 8x. I've now got that term. What I like about this method is it gives you a little heads up that you've got it right at the end, because you get the plus 24 term as well. And so this equals x plus 3 times by x squared minus 6x plus 8. And so that's the same as x plus 3. Normally you can factorize it at the end. This is no exception, because two numbers that add to give minus 6 times to give positive 8 are minus 4 and minus 2, and we've factorized it completely. I would actually write at the end, thus f of x equals, you know, we're just communicating, it doesn't take a second, x plus 3, x minus 4, x minus 2. As I define that as f of x, that should be nice and clear to the person marking my work. Okay, more of the same, really. It doesn't really get, that's a nice thing about factor theorem. It's pretty samey in the way the questions are asked. Okay, given that when f of x divided by x minus 1, the remainder is 9, write down an equation connecting a and b. So what we're going to do is we're going to plug 1 in. We're going to get a plus b. I love cubing and squaring 1, it's easy. Minus 7 plus 14. And that should equal 9. I sometimes encourage students to scribble out that bit. It's just there to remind you what you're actually doing, how factor theorem works. But this is the equation I wanted. Now, technically, they should give me the marks now because it's an equation, because it's got an equal sign in it, and it connects A and B. But let's tidy up a bit. A plus B minus 7 plus 14 is 7. Take it away from 9, you're going to get A plus B is 2. Okay, given that x plus 2 is also a factor of f of x, find the values of A and B. Well, okay, we now need to do the same thing with this fact. You always need two pieces of information to work out two unknowns. We're going to have f of minus 2 is going to be minus 2 cubed, well, that's minus 8a. Minus 2 squared is 4, so that's plus 4b. Minus 2 times minus 7 is plus 14, plus 14. Now, this is a factor of it, so it should equal 0. And so we're going to get minus 8a plus 4b is minus 28 after you add the two 14s together and take it to the other side of the equals. You could divide this by 4, or you could times this by 4. I'm going to divide this by 4 because it looks like it's cancels nicely. Okay, so I've got minus 2a. Let me just draw a line under that. Plus b is minus 7. I'm going to now write down that a plus b is 2. Watch out for sign errors when you solve this. I'm personally going to subtract here. Minus 2a minus a is minus 3a. Minus 7 minus 2 is minus 9. And so a is 3 and b is minus 1. And you've done it. A is 3, b is minus 1. Hope that wasn't too bad. This homework doesn't seem too bad, really. It seems quite nice. It's easy to make mistakes, so everybody does it. Okay, f of 4 is 0. So they're telling us that x minus 4 is a factor there. But we're going to actually have to plug in x equals 4. So 64 minus 16 minus 28 plus c equals 0. 64 minus 16 is 48. 48 minus 28 is 20. So 20 plus c is 0. So c is minus 20. Not too bad. Okay, right. Factorize f of x as a product of a linear factor and a quadratic factor. Okay, right, sure. Well, we already know that x minus 4 is a factor. So I'm going to do my little grid method division. Here goes. I've got x minus 4, and I need to find something which times is to give all of this. Let me write down f of x over here so it's nice and clear. X cubed minus x squared minus 7x, and then minus 20 that I've taken away there. Okay, so what do we need here? We need an x squared. And pause the video if you like and try and do this if you like this method. That gives you an x cubed, so we can tick that. But it also gives you a minus 4x squared. But we want a minus 1x squared, which means we need another positive 3x squared so that we've got that, which means that must be 3x. Then that gives us minus 12x, but we only want minus 7x, which means we need to add 5x, which means that must be 5. Got that now. And that gives me minus 20, which tells me I've done it right. So f of x is going to be equal to x minus 4, x squared plus 3x plus 5. Cool. And now the interesting bit, I can see it looking ahead, that this is the interesting bit. Show that apart from x equals 4, there are no real values of x for which f of x is 0. Now, this is bringing up an important aspect of cubics. Yeah, cubics can look like, to my mind, they can do three things with the roots. Yeah, cubics can look, firstly, the shape can be like, they can either look like that, but remember that if we move this up or down past this turning point or past this turning point, it would then only have one root. But it could have three roots. Yeah, three roots, roots being how many times it crosses the x-axis. Yeah, it could have three roots. It could have two distinct roots. Let's talk about distinct roots now, because roots can be repeated, which means they touch the x-axis. This has two distinct roots. It's got a root there and a root there where it just touches. Or it can have one root. And it could have one root in two different ways, really. It could have like no turning points, or it could have two turning points. But it could have one root. It could do something like this, or it could do something like this. You sometimes get them just kind of kinking rather than like actually generating a turning point. But this clearly has only one root. Now, what they're saying is show that your cubic only has one root. Now, algebraically, what happens in each of these cases? Well, an example where it's got three roots is where, you know, your cubic is something like that is your f of x, yeah? Because then you're going to get roots at 1, 2, and 3, yeah? An example of an equation where you get something like this would be like something like x minus 1, x minus 2 squared, because then you're going to have a root there, but you're going to have a repeated root here. Now, an example where you get something like this is where you've got what we've got here, f of x equals x, let's say x plus 1. I can't remember if it was plus 1 or minus 1, but x squared plus 3x plus 5. Now, that gives you one root there, but it doesn't give you any other roots because this doesn't factorize. And not only does it not factorize, because it's wrong to say it's only when they don't factorize, it's actually right to say the discriminant here is going to be negative. Remember, the discriminant is what you plug into your square root, yeah? And if the discriminant is negative, well, you can't square root a negative. Oh, by the way, you're thinking, what square root? I mean, think of the quad formula. The discriminant is that thing in that square root. The quad formula will give you no answers if you're square rooting a negative, because the square root of a negative doesn't exist. We allow for imaginary numbers, and if you've looked at that, great. But that's only in further maths. You know, in terms of like a real number coming out and actually being where it crosses the x-axis, that won't happen if you're square rooting a negative here. So what we need to show is that for our x squared plus 3x plus 5, that can never equal 0. Yeah. So assume, let's not assume actually, like consider, let's just consider x squared plus 3x plus 5. I'm going to say this has, well, equals 0. And I'm going to say this has no real roots as b squared minus 4ac equals, and I haven't worked it out yet, but I just know it's going to be a negative answer. Well, 9 minus 4 times 1 times 5, that's minus 11. Hence, now you've got to actually say what conclusion you can draw here. Hence, there is only one root. Only one value. That value is x equals 4, by the way. Where f of x equals 0. And the cubic will only go through the x-axis once. Okay, last one, last little one, little cute one. Okay, find the remainder when f of x is divided by 2x plus 1. Well, we're just going to plug in minus a half here, finishing on a nice easy one. 4 times minus a half cubed plus 3 times minus a half squared minus 2 times minus a half minus 6. That's a case of just working this out. That's going to be minus a half because you're going to have minus an eighth times by 4, which is minus a half. This is going to be a quarter times 3, so plus 3/4. That's going to become plus 1 and then minus 6. Well, minus a half plus 3/4. I think that's going to be minus, if you like, minus 2/4 plus 3/4, which is 1/4. And as plus 1 minus 6, well, 1 minus 6 is minus 5. If you add a quarter onto that, you're going to have like minus 4 3/4. If you wrote it down in a nicer way, that's minus 19/4. Yeah, if you write it down as a top-heavy fraction, perhaps it's a nicer way of writing it down. And that brings us to the end. Hope that was nice and straightforward, not too tricky. Probably just slip-ups holding you back there, but make sure you understand how to do the division. That's the key bit. Okay, all the best. Keep up the hard work and well done.